I would like to welcome you all this afternoon to our grand opening ribbon cutting ceremony for our wastewater treatment facility. I learned early on in the process that this is not a sewage plant. It is a wastewater treatment facility. It is a very scientific structure and really fascinating. I hope you'll all take the tours. It is just really something else to see what happens through the process of treatment of sewage. At this point, I would like to introduce our mayor, Dr. Alan Horn.
I too would like to echo Elaine's words and welcoming each one of you here today to tour this plant, to see what can be accomplished over a long period of time with the effort of many citizens in Melrose and many city staff. This project started some 6-7 years ago and took countless meetings, countless hours of work on the part of the Utility Commission, city staff, the city engineers to finally get to this point. And it's a process that because of regulations from the Pollution Control Agency is an ongoing process, and it's something that all of us in Melrose can be proud of. I think as we walk around this facility, and as I came down, I kind of thought this really belongs in a big city. But then really we are a big city when you look at our industry, the contributions to our community from Kraft and from Jenny O. In that sense, we are a big community, and that's why we have such a professionally run modern wastewater treatment plant. So I would like to encourage each of you to tour this, and I would certainly like to extend my appreciation to the Utility Commission, the city staff, and the city engineers, and to the City Council for all the work they've done on this project.
Thank you, Dr. Horn. Next, I would like to call on Dave Anderson, our engineer from Watermation. Dave, where are you?
I was trying to hide, Elaine. Do I want that? On behalf of the general contractor on this project, Acton Construction, and also on our behalf from Watermation, the engineers on the project, we would like to express our appreciation to the city, the operators here, the staff, for what we thought has been really an excellent working relationship that we truly have enjoyed. And as a small token of that appreciation, we'd like to present you with this plaque to mount on the entrance to the facility. As soon as you turn it right side up, then we'll be in great shape. And our thanks to all of you that have helped.
Thank you, Dave. Don? Don Salzman is our superintendent of this facility. I think he has a few words to say.
I'll be very brief. I would just like to thank everyone for coming down. I hope you all take the tour. We'll show you around the facility. And again, appreciate everyone coming down.
Scissors.
You want to take this?
Take this. Don't make me trip on that.
No, I won't do that.
Let's not do that.
Scalpel, please. Go ahead. Okay, what we'd like to do is have 15 to 20 people per group. It's a little bit easier to explain everything. And our tours will start right over here, and I'll take the first group, so we can have 15 to 20. Follow me over here.
You can take this. We have time on Monday? That's the pepper take, yeah. Just grab it. You betcha. I can help you then. Hey, please. Yeah, don't worry.
Oh, wait till you get through it.
Hey, did you go?
We're here with Daryl Hendrickson at the opening of the wastewater treatment plant for Melrose. Daryl is very familiar with the processes that take place here, and he will be giving us a guided tour, a special tour from LTV3. So, Daryl, will you take over?
Thanks, Cal. I've been involved in this project last 15 months as construction inspector for the $2 million remodeling, renovation, new improvements to the wastewater treatment plant. The structure on my right is the influent structure coming in, the raw wastewater coming from the residences and the three industries, major industries in Melrose. Those industrial areas making up about 80% of the wastewater coming into the plant. Okay, on my right here we have an air-operated cylinder that is controlled by a combustible gas monitor. This is one of the improvements in the plant. If it senses a combustible mixture coming into the wastewater treatment plant, this air cylinder will automatically shut off the influent coming into the plant. The room of the screen grit building, which is the first step of the primary treatment, some of the new improvements. Here you can see the combustible gas monitor and its light emitting diodes there, your lights that will alarm, that will light up if an alarm goes off. That automatically closes the air cylinder gate that we just previously saw. Okay. Okay, this is the basement of the screen grid building, where once the incoming wastewater first enters the building, it comes into the structure down below here and is pumped up by these screw pumps to the top of the... This is the combustible gas monitor that was connected to the readout panel up above that we mentioned. Automatically controls the shutoff to the plant if some type of toxic chemical should enter into the wastewater treatment process. Down here is a float setup that's also tied into alarm. Should these screw pumps go off, it will automatically activate a high-level alarm, which in turn the powerhouse is alerted, and city personnel then can correct the problem. Okay, down in here we have the partial flume, which records the gallons per day coming into the wastewater treatment plant. Therefore, we have an exact indication of the peak time of the day and the total gallons per day that did come through the wastewater treatment plant. Okay, here we have the flow chart. We mentioned the partial flow meter in the basement of the other building. This is what it's recording, the actual flow in million gallons per day, and it gives you the peak, and it'll record it for a 24-hour period. This is a typical flow meter. Sorry. You can see the flow here going along, and when industry comes online, it jumps up quite a ways and then back down to the evening hours. The building on the left, there's a screen grit building that we were just in. That had some extensive remodeling done on it also in this last project. It had 2 inches of a styrofoam insulation added to the exterior of it and a new stucco finish applied to the outside, as well as new heat recovery ventilation systems put in there. You get an overview. Behind that is a new lab administration garage maintenance area. The little white building in front here, of course, is the pump building that we were just in. And on the two tanks are the final filters that we'll be talking about a little later on. The building on the right over there is the building that houses the 360 horsepower electrical motors that run air compressors that produce air for the aeration tanks over on the far right. Looking off from the primary clarifiers, we have the new dike construction for flood control on the left. In the far back, the new silver diameter, the silver tank there, I should say, 75-foot diameter new tank that was constructed, has about 1,600 cubic yards of concrete in it and probably 60 to 65 tons of reinforcing steel. The bottom for the tank is approximately 5 to 6 feet thick and has 1,100 cubic yards of concrete just for the base of that particular tank. Inside of it is a floating gas holder cover that weighs approximately 265,000 pounds and travels 16.5 feet up and down. The cover will hold about 20,000 cubic feet of methane gas, as well as probably about 700,000 gallons of sludge. Here we have the open end of the primary clarifiers that have not been on the treatment process line since 1978 and now are back in duty. This particular primary treatment process involves the settlement of about 50 to 60% of the solids that settle to the bottom as sludge and will be removed and brought over to the digestion tanks that we'll talk about later on. Also, you have any scum or grease that will float to the top, and that of course is trapped in this particular trough right here, and that is pumped off and goes to the digestion tanks as well. The water then, of course, after we've settled the solids out and so on, is trickled over the weirs into the troughs, and that goes on into the next part of the treatment process, starting the secondary process in the white dome structures there behind us, the trickling filters, where we start the microorganisms to break down the pollutants in the wastewater. Part of the construction process, new fiberglass covers were installed on the primary clarifiers here, as well as the new building in back there that houses the drive mechanisms for the sludge removal and the scum removal mechanisms that are revolving at about 1 foot per minute in the tanks that we have. Routed out and filled in, and then it had an epoxy paint being applied over the tanks. We have mechanisms for the scrapers and flights that are in the primary clarifier tanks. As you can see, the chain and the sprockets and so on are of a non-corrosive plastic material, nylon. They revolve at approximately 1 foot per minute. So they are going through the tank, scraping sludge off the bottom and scum off the top, where both the sludge and scum will end up in the digester tanks. This is a site meter. We mentioned the sludge coming off the bottom of the primary clarification tanks, and that's just merely what it looks like in the pipes before it is pumped over to the digestion tanks for further breakdown. Down here we have a flow meter that indicates how many gallons and so on are pumped to the digestion tanks. In this room we have 3 new primary sludge pumps, valves, piping, so on like that. We can control each one of the 3 tanks, 2 of them or all 3 of them. These are automatically cycled to pump sludge so many minutes per hour based on the amount of wastewater we have coming into the wastewater treatment plant. Okay, this is the trickling filter, which is the first step in the secondary treatment process. It's where we distribute the wastewater over plastic media. This media provides a home for the microorganisms which are necessary to break down the wastewater. This is the aeration building where we have the 360 horsepower motors running the air compressors. This is where we get the compressed air for our aeration tanks, which will be next in the sequence of wastewater process. After the trickling filters, the wastewater flows into the large tanks here where we have compressed air that's forced into the wastewater. This aeration sets off a chain reaction. The oxygen keeps the organisms alive and provides energy for cell growth. The organisms consume the harmful pollutants, and the cell growth provides new organisms. This continuous interaction forms what we call the activated sludge. The activated sludge converts the suspended matter into heavier solids by a biological activity, which is the interaction of millions of microorganisms which live, work, and grow in the wastewater. They live on food, which is the wastewater, and oxygen, and grow by converting the food into new cell growth and byproducts. Activated sludge is developed when these well-fed organisms collect together and form clumps or flocks which are heavy enough to settle. The main ingredients needed to activate the sludge are a stable temperature, a chemical, biological balance between organisms and waste matter, food, and sufficient oxygen. Any extreme change, especially loss of oxygen level, can destroy this activation. Okay, after the aeration tanks, the activated sludge now goes to the final clarification tanks that we have here. You can see the incoming activated sludge wastewater on our right here, the darker chocolate brown liquid, and that is distributed around the perimeter of the tank, and eventually the activated sludge will settle to the bottom of this final clarification tank. The clear water then trickles off into the troughs in the square pattern in the middle of the tank. From there they go through piping and into the structure on the left as the clear water that now goes to the chlorine contact tank. Okay, this is the next step in the solid processing step of our wastewater treatment. We have had sludge coming from the primary clarifiers and also from the final filters. In this room we are thickening the sludge before it goes into the sludge digestion tanks in the other building. processing of solids produces two products. First, a stable anaerobically digested sludge, which can be used as an organic soil conditioner, and a digester gas, which is an energy source. In this room we have the sludge that we have taken off the bottom of the primary clarification tanks and also off the bottom of the final clarifiers. It's entering this room and is distributed off to two digestion tanks, approximately 40 feet in diameter. In those digestion tanks we will break the sludge down and also produce the methane gas that from there goes into the new 75-foot diameter tank for storage. Sludge has been digested, remains of course in the digesters for approximately 15 days in a temperature-controlled, oxygen-free, anaerobic environment. Their bacteria can live without oxygen, eat, work, and grow. This biological interaction destroys most of the pathogens or the sludge and produces a digester gas. This sludge, which is now stabilized, is stored in a digester storage tank. The sludge inlet follows right along this wall and is then stored into the new sludge storage tank, which contains approximately 700,000 gallons of sludge. The methane gas that is produced is also stored in the floating cover of that particular tank, and as mentioned earlier will hold approximately 20,000 cubic feet of methane gas that is used for energy production and fuel for our boilers. Okay, this is the pit area, so-called, as for the new sludge storage tank. The pipes that are extending out the side of the tank where we drain off supernatant, which is an almost clear liquid that settles to the top in the process of storing the sludge and also a little further breakdown. The red lines, of course, in here are your methane gas lines that are from this storage tank going over to the gas boilers that are needed to keep the sludge at a constant 95 degrees. This is the methane gas compression room. Both doors, of course, have to be closed during the normal operation of it because this is an explosion type atmosphere, and therefore the wiring and every other construction that was done here had to meet the codes regarding a gas explosion type atmosphere. The cover position indicator for the sludge digestion tank number 1, all tanks have an indicator similar to this. It indicates the number of feet that the cover is above its lower resting point. In this particular case, it's just about 3 feet above its lowest resting point, and it can travel a total of about 6 to 7 feet on this particular storage tank. Okay, this is one of the 2 new heat exchanger boilers that were installed into this construction project. The methane gas that is produced in our sludge digestion tanks is burned here as a fuel. We need a heat source to keep the sludge at a constant 95 degrees. This helps it to break down the sludge and produce your methane gas. My mention on this boiler also is that fuel oil is a backup source of fuel in case we do not have enough methane gas on site. So it's a methane gas or fuel oil type of boiler. This area here is the old lab office combination. We'll be taking you next into the new laboratory facilities, show you a tremendous improvement. Office is, of course, used for administrative work, including the regulatory compliance reporting and daily computer data entry. On here, they enter their records regarding the BOD, the lab tests, and so on. And also, on pressing a few buttons, can print out the MPC reports, the City Utility Commission reports, and do various types of graphing, getting an up-to-date perspective of how the plant is performing. Also in this area, you have the alarm system that is monitored from the office and is equipped with an automatic dialer telephone that automatically goes to the power plant to notify the personnel of any particular type of alarm. It's a voice synthesized alarm system, so it will explain what area an alarm has gone off. Laboratory where the operators perform various tests necessary for process control. These tests include BOD, total suspended solids, dissolved oxygen, phosphorus, ammonium, nitrogen, and sludge analyses. We also have information here for all three industries in town. Keep a daily log on temperatures, air temperatures, river temperatures. Different tests are performed on the river water upstream and downstream, as well as all the various samples that are taken from 4 or 5 different points in the process sequence of the wastewater treatment. Here we have 4 new automatic sampling systems that were installed as part of the construction process. The first one is getting an automatic sample on the influent wastewater. The second one is a sample that comes from the primary clarifiers. The third one is a sample from our trickling filters. And the last one on the right is an automatic sample from our effluent, or the water that is going out to the Sauk River. These samples are taken automatically so many times every hour, 24 hours a day, and go down into the compartment below them where they are refrigerated until the lab personnel can perform the required tests.
Basically, my title is wastewater foreman. And in a wastewater field, it includes all the operation and maintenance of the whole treatment plant, which is lab work, maintenance, painting, any jobs that you could find down here, we are involved in, and I'm basically in charge of it all. And water department, we take care of the well fields, the water, put the chemical in the water, run the lab tests on them, etc., etc. And on the collection system, the sewer system, we take care of the cleaning, repairing, and maintenance of the collection system. Basically, that's an overall view of the job.
What are your qualifications for this job? Do you hold a license or something?
Yeah, I hold a Minnesota Class A license, which is the highest license in the state of Minnesota in the wastewater field. And I acquired my experience by working with one of the best operators in the state, Don Salzman. I learned 99% of what I know from him.
Then this is a type of license you can obtain by on-the-job.
Yeah, you can. They require you to have, I believe it's 8 years of experience now to be even qualified to take the exam, the A exam. And you go before a board down in the cities. It's a board of health. There's a doctor on the board and a lawyer and a top operator, and then I forget the other one. It's anyway, there's 4 people on the board, and 50% exam and 50% oral when you go before the board.
How long have you had your license?
It'll be about 2 years now.
You've been at the job for a number of years then.
Yeah, I've had my A license for 2 years, and I've been working down here for better than 15, yes.
Okay. Then you must be pretty familiar with the capacity of what passes through the system.
Oh yeah, absolutely,
And,
absolutely.
Has been a sort of expansion of sorts, has it not?
Yeah. Mm-hmm.
Maybe you can give us some details on that.
On the
Amounts that go through.
of that comes through the plant. Well, on days when Genio runs, we take in approximately 2.5 million gallons of sewage. And in that sewage, there's about, an average of about 300 parts per million of BOD. And the BOD is a process by which we measure the solids in the sewage. BOD is biochemical oxygen demand is basically what it is. Organic materials break down and they use air, and we use this process to measure the pounds that come into the plant.
I see, I heard Darrell use BOD.
BOD, yes. I would say we get about approximately 3,000 pounds of BOD into the plant per day, average.
Now, well, do you foresee that this expansion of this plant is going to be sufficient for a number of years now?
To handle what we've got coming in right now, yes. It should take care of any future loads coming in for a few years, yes. As far as phosphorus and ammonia removal, that we're waiting to see on what we have to do with that. The way the plant sits now, it don't take out enough of the phosphorus and ammonia that the state requires us to, so we may have to do something with that.
I see. How would you describe this new facility or the remodeling of it or the expansion of it?
Oh, great.
Quite a change.
Yeah, it's really going to make a difference for us. Like the primary clarifiers up on top, they increase the capacity of the plant by 25 to 35%. And the new lab building here was a long time coming with the state requirements to run all the testing procedures that we have to go through that it really makes it nice working now.
Yes, I had seen the old lab.
Yeah, yeah, you did see it, yes.
Is there anything else you would like to add to this that you feel people might benefit from knowing?
Well, I just encourage anybody to come on down, and there's always somebody on duty, and we're glad to give tours to anybody who wants to come down, and it's a lot easier to explain to people when they're down here. So if anybody is really interested, just come on down. Most of the time you don't have to make an appointment. We can break somebody loose.
Well, it's very interesting. Everyone should, if you have a chance.
Yes.
And is interested in it, should try to get down.
Yeah, it really is. It's a facility that the city of Melrose should be proud of, really. And I'm proud to be able to say that I worked down here and then be in charge of it, too. That is quite an honor for me.
Good for you. Well, thank you, Jim. We appreciate your time today, and good luck.
Yeah.